Hello guys, welcome again. In this video, I'm going to explain how to write Verilog code for full adder using data flow model. So I presume that you know how full adder works and all the output expressions for sum and carry. If not, you please watch the previous video, that is full adder coding in structural model. There I have explained in detail about this full adder, so you can get a brief idea. Then you can watch this video and you can continue coding in data flow model. So as I already told you, the output and input won't change because they are ABC and some carry not. If you take a block of full adder, then the input terminals are these three and the output is sum and carry not. So in the data flow model, you use the keyword assign. So you are assigning the output of A XOR B XOR C to sum directly, and the output of this expression, after evaluating this expression, the output will be assigned to carry not. Okay, so this is as simple as that, and that's it. By these two statements, you are done with writing code for full adder in data flow model. So in to synthesize the circuit, you have to write the test bench, which is similar. It doesn't matter in which level of abstraction that you're writing coding, that it might be in data flow model, structural or behavioral, but the test bench intention is to test with all possible input combinations. So you can here you can see all 8 input possible combinations. You can please refer to my previous videos. There I explained about why reg is used and why while is used, what is this dot notation for these variables and all, and also about this dollar monitor and dollar finish. For time being, you just look at this test bench so that you can try it out on your own. So here I check the all possible combinations, and after 20 nanoseconds, because the time directive I specified for each unit as 1 nanosecond, so this will be done. And let me check the syntax and show you the waveforms which won't vary. As in structural model, I haven't shown you the RTL schematic. So in this, I'm going to show you the RTL schematic also. First, let us check the waveforms in detail. Okay, here you can check all possible combinations for 0, 0, 0 and randomly. If 0, 1, 1, then carry is 1 and sum is 0, and for triple 1, both should be 1. So you can check all these combinations. So you can try out this on your own, and you can watch this video if you have any doubt. Let me check the RTL schematic. Okay, so to check the RTL schematic, you go for synthesis, and here you can click on view RTL schematic. There you can look at the synthesized figure by the synthesizer. So it will synthesize on its own. So this is what it look like. Okay, so this is how the RTL schematic is, and these are primitives. This is 2 input AND gate, and this 3 input OR gate, and this is also a 2 input. So AND 2 means it's 2 input AND gate, OR 3 means it's 3 input OR gate. Okay, and it's XOR. These are all primitives that are present in the Verilog software. I mean Xilinx software itself. So this is how the schematic would be. Hope you guys learned something new, and please try to code on your own so that you will get a brief idea on coding on yourself. And in the next video, I'm going to explain how to code for full adder using behavioral model than using instantiation and all these things. So that's all for this video. See you in the next one.